Distance time graphs. There are going to be two tutorials for distance time graphs. This one about the shape of the graphs and the next one about calculations with graphs. Here's a set of data, distance and time data taken for the motion of an object. To illustrate this, we'll use this story about a gentleman who arrives at the station. He parks his car. He's got to walk 28 meters to get to the train. To start with, he's at 0, starting point, locking his car doors. He then starts walking at about 2 meters per second, and he gets to 8 meters where he checks his pockets for his wallet. He finds he's got it, so he carries on walking, running this time, getting to the stairs and going up a little more slowly, getting to the train and stopping outside the door waiting for them to open. So the data looks like this. And what we need to do is plot it on a graph. So we take the first point and make it the first point on the graph, 0, 0. Then remember, we take the x values first, so 1, 0 will be there. And we carry on doing this until we get to the last one, which would be 20 on the x-axis, 28 on the y-axis. When we take the points away, we get the straight lines that look like this. Now, thinking about the motion and looking at the data, we can see where the lines are horizontal, the object is stationary. So the first horizontal part was when the person was at his car door, standing still. The second horizontal part was when he was 8 meters away, checking for his wallet. And the last horizontal part was where he was 28 meters from his original point, waiting for the train doors to open. The other sections is when the object was moving with a constant speed. And we can see from the slope of the curves that the steepness determines how fast it's going. So the steepest would be its fastest, and the least steep would be its slowest. So to summarize the shape of that particular graph, if it's a straight line, it means constant speed, and the gradient or slope determines how fast the object's going. The horizontal sections tell you that it's a stationary object, and if the horizontal line is above the x-axis, then the object is standing still away from the starting point. If it's on the x-axis, it's actually at the starting point. Now let's take another situation where this person, first of all, locks the car door, walks a certain distance, at that point checks for his wallet, finds that he hasn't got his wallet, so he's got to go back to the car. So off he goes back to the car and gets there and does whatever. When we plot that graph, it's going to look like this. Again, the horizontal lines indicate where the object was standing still. So initially at the car, checking the wallet, back at the car. The slopes or the straight line sections indicate constant speed. If it's sloping up, in other words, looking at it from the left to the right, if it's sloping up to the right, then it's constant speed away from the starting point. If it's sloping down, then it's constant speed towards the starting point. So to summarize, constant speed if it's sloping up away from the starting point, if it's sloping down towards the starting point. If we had a look at the data for an object that's accelerating, looking at that third column, you'll see that the distance moved for each second is increasing. In other words, the object's getting faster and faster. Your graph looks something like that when you plot the distance versus the time. So you get that curved shape for acceleration. If it was decelerating, in the third column, check the distances traveled, and you'll see that the distances traveled for each second is getting less and less because the object's getting slower and slower. In other words, decelerating. When you plot the curve, you get something like that, which is just the upside down version of the acceleration graph. If you put them all together, here's an object that accelerates, it reaches a maximum speed and it continues at that speed for a while, then it decelerates until it comes to rest and it stays at rest for a while. You get that sort of graph. If I draw it without the points, there's the curve for acceleration, constant speed, deceleration, and stationary.